Alright, in this video, we will talk about analytics at the highest level. So we will see what they mean, why they're important, and get some terms and confusion around some terminology out of the way. We will also cover in a lot more detail what the rest of this course is going to include. So first of all, let's cover who needs analytics. Is it only for the PhD data scientist, or is it for others as well? Actually, analytics are needed by anyone who needs to make a decision. And we see analytics in operation all around us. Governments analyze and predict pensions and healthcare bills, and they do so using time series analysis and other regression mechanisms. Google can calculate whether you will or will not click an ad, and that's because they are paid if you click the ad they present to you. So they are interested in knowing what is the likelihood of you clicking on something. Amazon can show you what you're going to buy next, and they do that using association rules, something we will cover in the course. Insurance companies predict who will live and die or have an accident, and these are all classification problems that we will also cover in the course. Netflix again wants to know what you would like to watch next and gives you those recommendations. And these come from recommender systems, and these are also things that we will cover as part of this course. That said, let's switch to some slides so I can walk you through some of the key concepts and terms that we will encounter going forward in this course. So first of all, what are analytics and what do we mean by those when we talk about it in this course? And especially more so for managers who are really interested in profiting from data. So analytics are data-based actionable insights. Now, each of these phrases is important here. They are data-based, which means opinions are not analytics. They are actionable, which means that they drive decisions. If they don't drive decisions, well, they may be very interesting or they may be entertaining, but they really are not analytics. They're more like stamp collecting. They're insightful, which means that they uncover things that were not known to us before. So they help us in understanding more from the data that we have. So let's now talk about the course. What we will have in the course, the first part, we are going to focus on data exploration. Why is it important? And we will cover visualization and several exploration techniques. Again, there will be two components to this exploration. One will be the managerial perspective, where we will not go into any code or math, but we will look at what kinds of techniques are available that you can ask your teams and analysts to cover. And then for the practical explorer, we will also have code that will allow you to see how actually to do data exploration and what kinds of things to look for when you are given some data that you don't know much about. And those situations actually are quite common. A client or your manager might give you, hey, here is a thumb drive with some data, or maybe there is a folder on Dropbox. Go pick up some data from there. It relates to my complaints that I've received from my customers, or outages, or sales data, anything. And you have to figure out what does it mean and what does the data tell me when I go poke under covers without doing anything too advanced. So we will cover that. In the second part, we are going to cover data engineering. And what we mean by that is all the twisting and reshaping of data to make it actually practical, of practical use to the situation or to the problem that we are trying to solve. And the reason you have to do this is because data very often, and in fact, in most situations, is not really created for the data scientist or for the analyst. It is created as part of this work as usual, and it has to be reshaped into certain formats and fixed and transformed so that it becomes useful either for modeling and decision making or just for presentation purposes as well. So we will cover all the different techniques that are available to us for data engineering. And in the third part, and this is going to be the largest part of the course, once we have done the data exploration, we understand how to twist and shape the data to make it fit what we need it to do. Then we come to the decision making aspects, where we will cover modeling, we'll cover regression, machine learning, AI, also known as deep learning, time series, natural language processing, and several other techniques. And most of these topics, we will create these as standalone courses. So you can pick the ones that you are interested in for solving the problems at hand for you. So, what are business analytics? And we talked about it. They are data driven insights. Now, analytics, they can vary in sophistication, and data can be presented in different forms. So it can come as raw data or near raw data. So just counts, observed facts, readings from a sensor, web logs, and they can be presented as is to the educated audience who can make some sense out of that. But very often we encounter summarizations, which means you take the data, you filter it, sort it, pivot it, average it, do some descriptive statistics on it, create subtotals, do a group by. Some of these operations can be done to make the data more useful for consumption as for your need. The third thing, and I distinguish it from regular summarizations, is time series, because time series is a very important form of data. It means there's the same measure but being compared along the time dimension. So we will be covering time series as well, and forecasting and predicting time series in this course as well. And finally, predictive analytics, which means we take the data, we use some technique to identify patterns in the data, to classify information, or to make a prediction, or to cluster or get groups of similar items together. So those kinds of things can also be, they're also analytics. The one thing I would add here is that greater sophistication, more complexity, more mathematics does not definitely mean superior analytics. Fitness for purpose for the use case and for the problem at hand is more important. If you're trying to cross the road, you look left, you look right, and then you move. You don't need any machine learning to do that. So always keep that in mind. We are not smitten by the elegance of algorithms or of mathematics. We are trying to profit from data, which means the simplest path to take advantage from the data that we have in our situation. So, how do analytics support a decision? So, analytics can support a decision by providing facts and numbers to a human. And that is, in fact, the most common use case. And analytics come in the form of a report. A person is in the loop, thinks about it, and makes a decision. And it is a better decision because there is more information available to the human to make that decision. Second is recommendation of a course of action. So the machine may actually recommend to the human that, hey, this is what you should do based upon what I see. But the final decision is still made by the human. There is a human in the loop. And finally, that probably would be the more advanced case where we are confident in the ability of the machine to arrive at the right decision, where they can automatically make a decision and execute. So, for example, when you apply for a credit card online, you get normally a very quick decision within 30 seconds or so. And most of the time, that decision is made by the machine. Sometimes the machine cannot decide, or it comes at a decision to not extend credit to you. You will find that your experience, and my experience has certainly been that in such cases where the machine cannot come to a firm decision, it defers to a human. Even though it does automatically make a decision, it can still bring a human in the loop. And one other thing I wanted to highlight was the type of decision making that needs that has to be done. Again, this relates to the timing. So there are one-time decisions, which means I need to go and discover some data that has been provided to me at a point in time and do a one-time decision. I may or may not have to do that decision making again and again, or may have to do it very far away in the future. And at the same time, there are also repeated decisions. These are decisions that often need to be made at large scale and they require automation. And for such decisions, even the smallest improvements in efficiency or performance can actually give us huge savings. So keep that in mind. The scalability of your solution is often driven by the kind of decisions analytics support. So, something to bear in mind as we look at solutions going forward in this course. So, how do analytics show up? How are these consumed? So, they show up in many different forms. The most common form is presenting data in an analytical dashboard or a report. So basically, the thing I said before, you provide information to a human to support decisions that they make. The next is embedded analytics. So analytics can actually be embedded in an application and provide intelligent responses based upon user interactions. And one example of that is a lot of coding and programming IDEs. They now contain suggestions. So as the coder is coding something, it will provide suggestions as to how to make the code more secure, for example. So all of those things are happening in real time, and there is analytics that's powering that uh, those intelligent responses. And finally, we have fully automated analytics that they are embedded in a process where the machine decides whether to go left or right in the decision making process. And again, the credit card or credit permissioning process that I spoke about earlier is one example of that. Another thing, and now we are getting into the area where we talk about the terms you are likely to hear when you talk about analytics. So you will hear descriptive analytics versus prescriptive. And quite honestly, I think the distinction here really does not matter. What we are trying to do is to profit from data, get an advantage, no matter what the tooling is or what you call it. But still, let's just go through what these things mean. Descriptive analytics describe what has happened in the past, and you look at things like the averages, the median, and such stuff. You present bar charts or time series lines, line graphs, etc. The next is predictive analytics, and we really talked about this, where we look at patterns in the data to make a prediction for the future. And prescriptive is where the machine makes the best course of act, decides the best course of action based upon a certain rule, and the rule could actually be driven by a machine learning or a deep learning algorithm. And there are other phrases as well that you will hear about when we talk about data analysis, and those are all similar in meaning. Uh, and other things, data mining. Before this was called data science, a lot of the work that we do today, including things such as regression, k-means, and other techniques, they were part of a field of study called data mining. In fact, if you look at books from 15 or 20 years ago, all of the same things that we study under data science today, they were studied as part of data mining. Data science itself is something that combines not just the programming skills and the knowledge of mathematics to run the algorithms and apply them to data, but also domain expertise. And this is really what distinguishes a data scientist from a software engineer or a software developer. It is expected that the data scientist expends the time and invests effort in obtaining domain expertise. So that's another term you might run into. And finally, data analysis itself is everything relating to the inspection, cleansing, transforming of data, and supporting decisions. Next, you may also hear terms such as data processing, big data. And again, data processing is more about acquiring data, and more so when the data is just coming in at a huge, at a high velocity. And this includes things such as weblog data or click data, etc. And big data refers to data sets that are too large for traditional data processing systems. However, because yesterday's supercomputer is today's watch, the definition of big data by is, in a sense, it keeps changing. So what was big data yesterday is something that you can manage on your phone today. So again, this is something to bear in mind. Finally, let's also talk about what is the meaning of AI, machine learning, and deep learning. And a very good explanation of this appears in a book on deep learning by Francois Chollet, and I highly recommend if you are interested in learning more about deep learning, that's a great book to buy. Um, so artificial intelligence is sort of the umbrella term that includes all things that we can do to automate the intellectual tasks that are performed by humans. And this includes rule-based systems, which means if there is a if then else rule, which means if you see red, then stop. If you see orange, then prepare to stop. If you see green, then keep going. So all of those rule-based things are part of AI. In fact, the origins of artificial intelligence were in something called symbolic AI, where it was assumed that a very large set of if else rules can be used to capture intelligence, what we know as intelligence. Machine learning is a part of AI and is a collection of statistical techniques to identify patterns in data for classification, predictions, and for clustering. So again, we will be covering most of the key machine learning algorithms in the remainder of this course. And finally, there is deep learning. Deep learning is what we often call AI, um, even though, as I said, AI is the larger term, and which also actually speaks to the fact that there is confusion around terminology here. And even though there may be some confusion, it really does not matter at the end because what we are trying to do is to gain an advantage using data and the techniques that we already have. So deep learning is based upon layers of data transformations using neural networks. And this is again something we will be covering in this course. And finally, the distinction between traditional programming and machine learning. In traditional programming, you have data and a human provides the rules to apply to that data, and that gives us answers. In machine learning, this equation is turned around a little bit. We provide the machine with data, and we also provided the answers that we have obtained from the past. And based upon that, the machine figures out the rules. And then it applies those rules to data that comes to us in the future to make a prediction. So there is a difference between how machine learning approaches arriving at decisions and how traditional programming works. The challenge with traditional programming is that the rules may be too complex for us to codify or even to learn about, whereas a machine can actually spot the patterns, figure out the rules from that, and then use these rules to answer the questions when new information becomes available in the future. But in the end, as I have repeatedly said, our goal is really to profit from data. And we are free to use any or all computational techniques that can give us an advantage. So for the rest of this course, we are going to talk about business analytics and data science in a rather in a sort of interchangeable way. And I like the phrase business analytics because it is more, is wider in scope and is not just limited to some mathematical or other techniques. It really is about how can you use data to gain a competitive advantage. So, all right, welcome. And the final slide here, it speaks to where we see data science and analytics and business analytics applied. The first uses for this, of course, were marketing, online advertising. With the explosion of activity on the web, there was a lot of work was done, and it was driven by the profit motive, which is, of course, the biggest driver for any advancement. And this is where the science has developed the most. But at the same time, just about every functional area in any business can benefit from using data. And we have seen examples of this in just about every field. So, with this, let's launch into the course itself. And the next next chapter is going to be about exploratory data analysis, or EDA as it is called. We will begin with a managerial overview, and then we will go into some of the coding aspects as well, should those be of interest to you. And I hope you enjoy your time as you learn. Thank you.